the arc length is 11 centimeters. So, dear student, let us proceed with the second question. That is, calculate the length of an arc which subtends an angle of 135 degrees at the center of the bicycle wheel, whose spoke length is 7 centimeters. So this time we have the bicycle wheel. Of course, this is the bicycle wheel. I'm sure you know it. That is the spoke length. That's from the center to somewhere point of the circumference of that bicycle wheel. That is given as 7 centimeters. And also there is a central angle that is 135 degrees. We're supposed to find the length of an arc. So now, let us start with the given. We have the central angle, that is theta, which is equal to 135. But again, we have the length of the spoke, which is the same as the radius of that bicycle wheel. That is R is equal to 7 centimeters. Now our intention to find the length of an arc, that is L. So our general formula, that is L, is given by circumference, that is circumference the circle, that is times the central angle over 360. But circumference of the circle, this one is the same as 2 pi r, that's circumference of the circle, times the central angle over 360 degrees. So in this case, we have, that is 2 times, now pi, that is 22 over 7. So pi, we have 22 over 7 times r, that is radius, the length of the spoke, which is 7 centimeters. Then times the central angle. Now our central angle is 135 degrees. Now this one over 360 degrees. So we simplify by 7 is 1. Of course, that one will be 2 times 22. That is 44, then times 135 degrees over 360. So you can continue simplifying. Now in this case, the arc length of a bicycle wheel will be equals to 16.5 centimeters. Therefore, the length of an arc, length of an arc of bicycle wheel is 16.5 centimeters. So, dear students, let us proceed with another question. That is question number 3. This time we are supposed to find the angle subtended at the center of the circle of radius 12 centimeters by an arc of length 30.8 centimeters. So we are supposed to find the central angle, that is theta. So that is question number 3. Now given, we need the central angle, that is theta. But again, with the radius of the circle, that is r, is given by 12 centimeters. And the arc length, that is L, this one is equal to 30.8 centimeters. We are looking for the central angle. Now from our formula of finding the arc length, we said that is arc length is equal to 2 pi r, that is the circumference of the circle, then times central angle, this one over 360. So from there we can make theta the subject. So you have to do cross multiplication, that is 360L is equal to 2 pi theta. So to make theta the subject, you can divide by 2 pi r, that is by 2 pi r. So in this case we have the central angle theta. This one is equal to 360L over, that is 2 pi r. Then you can simplify here, that is theta is equal to by 2 is 1 by 2 is 180. So we have 180L over pi r. So in this case theta is equal to 180 times L, that is arc length. Arc length in this case is 30.8 centimeters. That is 30.8. Then divide by, now pi, that is constant, we have 22 over 7. So this is divided by 22 over 7 times radius. Now our radius is 12 centimeters. Divided by 12 centimeters. Rearranging this the same as 180 degrees times 30.8, then times 7 over 22 times 12. So dear students, you just simplify this product of numbers, that is 180 times 30 times 7 divided by 22 times 12. The answer will be so the central angle theta will be equals to 147 degrees. Therefore, we say the central angle that is theta is equal to 147 degrees. So my dear student, we proceed with another terminology in a circle, that is radian measure. Now what does this mean? That is the measure of the central angle subtended by an arc that is equal in length to the radius of the circle. That means the central angle can be represented either in degrees or in radian measure. And in this case, we want to find the relationship between the degree measure and the radian measure. Now, dear student, consider this is our circle. Of course, from the center of this circle to the point of the circumference, this we call it is a radius. Now, for one complete rotation of this circle to make 360 degrees, that is just to say one rotation of a circle, this is equivalent to 360 degrees. that is for a complete circle. To rotate from this point, then on complete this rotation, we have 360 degrees. But again, but also one rotation of a circle, this time in radian measure, is the same as 2 pi, that is in radian. So you can see the relationship. That is, one rotation of a circle is equivalent to 360 degrees. But also, one rotation of a circle is equivalent to 2 pi radian. In this case, this implies that, this implies that is 2 pi, that is in radian, is equivalent to 360. Now on dividing by 2 from both sides, we have, that is 2 pi in radian, which is equivalent to 360 degrees, divided by 2, we have pi, that is in radian. This one is equivalent to 180 degrees. That means in measurement, when we have 180 degrees, that one is equivalent to pi radian. Pi is the same as 22/7. Now suppose we want to find the equivalent between radian measure and degree measure, but this time when radian is 1. So in this case, divide by pi from both sides of equation 1 above. This is our equation 1. So in this case we have pi, that is in radian, which is equal to 180 degrees. So divided by pi, so we have 1 radian, this one will be equals to 180 degrees over pi. Now but pi, this is the same as 22/7. So in this case, we say 1 radian will be equals to 180 degrees over 22/7. This one can be written as 180 degrees times 7/22. So in this case, just take 180 degrees times 7, then divide by 22. In this case, we have 57.2727 proceed to infinity, that is in degrees. So on making approximation, this one will be equivalent to 57.3, that will be in degrees. So in this case, we conclude as follows, that is 1 radian That is 1 radian. This one is approximately equals to 57.3 degrees. So in our computation, we can use this relationship or can use this one according to the nature of the question. Now, my dear student, we have an example here. That is an arc of a circle of radius 2 centimeters subtends an angle of 1.2 radians at the center. Calculate the length of the arc. So that is 1. That is radius. This one is equal to 2 centimeters. Then the angle is 1.2 radian. Calculate the length of the arc. We need the R. This is how much? Now, from our previous discussion, you remember the formula for finding the length of an arc. That is L is equal to, that is circumference of the circle, this one times central angle over 360. But this time, our angle is given in radian. So remember that, but 2 pi, that is in radian. This one is equivalent to 360. So dear student, L is equal to 2 pi r times the central angle over 2 pi. So on simplifying by 2 pi that is 1, then L is equal to r theta. Therefore, in our question, L is equal to, now we have R is 2 centimeters, that is 2 times. Then we have theta, that is 1.2. It is 1.2. So in this case, L will be equals to 2.4 centimeters. Therefore, the arc length L is equal to 2.4 centimeters. So my dear students, let us proceed with the example 2. This time we are supposed to convert the given degree measure into radian measure. That is, convert the following degrees into radian measure. A, we have 60 degrees. We are supposed to convert into radian. So A, that is 60 degrees. I'm sure you know the relationship between radian measure and degree measure. That is pi in radian. This is equal to 180 degrees. Now what about when it is 60 degrees? We need to find the radian measure. So again, do cross multiplication this way and that way. So in this case, we have 180 degrees xc, which is equal to 60 degrees times pi. That will be in radian. So divide by 180 degrees from both sides. So in this case, we have XC simplify by 60 is 1, by 60 is 3. So in this case, we have pi over 3, that is in radian. So therefore, we say 60 degrees, this one is the same as pi over 3, that will be in radian measure. It will be in radian measure. B, that is 45. You have 45 degrees. Again, remember the relationship between radian measure and degree. That is pi, that is in radian. This one is equivalent to 180 degrees. Now, what about when it is 45 degrees? This one is equal to how much? Do the same. Do cross multiplication. That is 180 degrees times y, which is equal to 45 degrees times pi. So divide by 180 degrees from both sides. That is 180, again 180. So in this case, we have y is equal to, now only simplifying, by 45 is 1, by 45 this one is equal to 4. So we have pi over 4, that is in radian. So in this case, we say 45 degrees, this one is equivalent to pi over 4, that is in radian. So my dear student, we have a third question. This time we're supposed to convert the given radian measure into degree. That is, convert the following radian into degree measure. A, with pi over 6 radian. So number 3, that is 3, A, we have pi over 6, that is in radian. We use the same relationship, that is between degree measure and the radian measure. That is pi in radian, this is equivalent to 180 degrees. Now, what about the pi over 60? This time we have pi over 60 in radian. This one will be equal to how much? That is x. You do cross multiplication this way and that way. So we have pi times x. This one is equal to 180 degrees times pi over 60. Now divide by pi. Divided by pi, we have x is equal to, now try to simplify, by pi is 1, but by 60, that one will be 30. So this time we have 30 degrees. So in this case, pi over 6, that is given in radian, that is radian measure. This one is equal to 30 degrees. My dear student, I'm sure we're together and you are enjoying this revision of the topic of circles. Let us continue with B. This time we have pi over 2 given in radian. That is pi in radian. This one is equivalent to 180 degrees. Now what about pi over 2? When it is pi over 2 radian, this will be equals to how much? So in this case, we have, that is pi times y. This is equal to 180 degrees times pi over 2. Now dividing by pi from both sides, we have y is equal to, now that is 180 divided by 2, that is equal to 90 degrees. So in this case, we say pi over 2, that is in radian measure, this one is equal to 90 degrees. I'm sure now you remember how to convert degree measure into radian measure, but again radian measure into degree measure. So my dear student, let us proceed with another terminology in this topic of a circle. This time we have the area of a sector. So this is our circle, and of course here we have a sector. Now our sector is named as X or Y. Of course it is shaded. So it's just a part of the circle. So this sector is just a part of the complete circle. And our interest is to find the area of this sector. So in this case, I'm sure you remember the formula for finding area of a circle. That is area of a circle, this is given by pi r squared. But this sector is just a portion of the circle. So in this case, that is sector or area of a sector, area of a sector, it will be theta over 360 then times pi r squared, because that portion of a sector is represented by theta over 360. So if we want to find just the area of this portion, just a matter of taking theta over 360 times area of a circle. In this case, this is the general formula of finding the area of a sector. So this one is in terms of degrees, when you are given theta in degrees. Now what about in radian measure? I'm sure you remember the relationship. That is, we say 2 pi in radian, this is equivalent to 360. So in this case we say area of a sector will be equals to theta over 2 pi times pi r squared. So on simplifying, we have area of a sector, this one is equal to 1 over 2 theta times r squared. So this one will be in terms of radian, that is when theta is in radian measure. And of course this one is when theta is in degree measure. So my dear student, I'm sure we're together. Now let us see examples of using our formula. The first example, that is a sector of 80 degrees is removed from a circle of radius 12 centimeter. what area of a circle is left? So here we have a circle. Now in this case, in this circle, the radius is 12 centimeters. A portion of this circle is removed, which is this one. And of course, this represents a sector. And the central angle is 80 degrees. Now, what will be left in your circle? Now, given we have radius, that is r is equal to 12 centimeter, and pi, this is equal to 22/7. And of course, in our question, the central angle is 80, that is theta. This one is equal to 80 degrees. So in this case, let us find the area of a circle, and then find the area of this sector, and find the difference between the area of a circle and that of a sector. We are going to get the region which is left after remove of a sector. That is, area of a circle is given by pi r squared. So in this case, we have 22/7 times radius is 12. This one is squared. So in this case, the same as 22/7 times 12 squared, that is 144. Now the area of a circle, in this case, is equal to that is 452.5714. That is area of a circle. That is area of a circle. Then we proceed with the area of a sector. Now in this case, area of a sector is given by, that is area of a sector. This one is equal to theta over 360, that is times pi r squared. So in this case, we have, that is 80 degrees over 360 times 22/7 times 12 squared. Now in this case, the area of a sector is equal to So in this case, the area of a sector is 100.5714 squared centimeters. So in this case, we say the area left, that is, I call this is area 1, this is 1, this is 2. So the area left, this is equal to A1 minus A2, which is the same as 452.5714 minus 100.5714, because all these are given in centimeter squared. So in this case, the area left, this one is equal to, so on subtracting, we are going to left with so the area left on remove of this sector is the same as 352 squared centimeters. So student, the second question, That is, calculate the area of a shaded segment of the circle shown in the figure below. So this time we have a sector, that is a sector with a shaded segment. Our interest is to find the area of the shaded segment, which is this one. So in this case, so my dear student, you remember the formula for finding area of a sector. That is number 2. That is area of a sector. This one is given by the theta over 360 times, that is pi r squared. Now let us find the area of this sector. So in this case we have, that is 63 degrees over 360 times 22 over 7 times radius, that is 10. So we have 10 squared. So in this case, the area of a sector is equal to the area of a sector is equal to 55 centimeters squared. So again, let us find the area of this triangle. So the area of a triangle, that is area of a triangle, that is the same as a half times base times height. So in this case we have a half. Now base, that is 10. Then height, that will be 10 sine of 63. That is how to find the area of our triangle. Since there is angle included here, it's just a matter of taking a half. Our base is 10, then our height will be sine of 63. So in this case we have the area of the triangle is equal to 44.55 squared centimeters. Now the area of the shaded segment, area of shaded segment, this one is the same as 55 minus 44.55. Just take the area of a sector minus area of a triangle. So in this case we have, that is 10.45 squared centimeter. That is the area of the shaded segment. Now dear student, it is my hope that you enjoyed this lesson. Now let us have an assignment concerning to the subtopic of centroangle. Maybe that is question number 3, is find the area of a sector of 7 radians at the center with radius 4 centimeters. But again, we have find the length of the arc with radius 6 centimeters and a centroangle is 40 degrees. And another question, that is a pendulum of length 26.67 centimeters moves through an angle of 22.5 degrees. What is the length of an arc made by its tip in one swing? And the last question, that is calculate the area of a sector of a circle which subtends an angle 45 degrees at the center of a circle with radius 4 centimeters. So my dear student, make sure that you try doing these questions It is the assignment for you. You can discuss with your fellow. I'm sure you are going to manage doing the assignment. It is my hope you enjoyed this lesson of basic mathematics when we were discussing some concepts in a circle, subtopic of the center triangle. So till next time, have a good time and make sure that you are not missing another lesson of basic mathematics. Welcome.
Kipindi cha Darasa Online kimeletwa kwenu na Chuo Kikuu cha Sauti Mbeya.